With apologies, this one is a bit longer of a lesson. It's about measures of center, and we have several measures of center, and we do have some math examples to include. So I will go through this best I can, but there's certainly more slides involved in this one. First of all, what are the measures of center that we're really dealing with? So you would think that center just referred to one thing, but when you've got a data set, there's a lot of different ways to talk about what is in the middle. We could say that there are more of them here, that this is what we actually get if we line things up and we go to the middle. So anyway, we've got mean, median, mode, and mid-range that we will deal with, and then there are a couple of different ways to calculate means, so we're going to look at that. Within each one of the following slides, we'll take several slides about each one of these, so you don't have to write a definition or anything right now if you're taking notes, but these are the concepts that we're going to go over. So first of all, let's get going with mean. Often this is really called the arithmetic mean, but we as people seem to shortcut everything, so we just refer to it as mean. And down at the bottom, you'll see on that slide where this is that idea that most people that don't deal with statistics or professional journalism or anything will just call an average, but you should not call it an average in statistics class. So one little way to kind of stick this in your head is you might tell yourself, I'm always big on how are you going to remember this? The average person is mean. I'm not saying that that's true. You can decide that for yourself. But instead of calling it an average, we're going to call it a mean. And the mean of the set of the data is found by adding all those data values and then dividing by the sum of the total number. You have a little bit of notation here. This is actually that symbol that's in front of the X, that's the weird looking little E, is referred to as sigma. It's a capital Greek letter, sigma. And it means that you need to add up all of whatever's after it. So when you look at this formula, the mean, the symbol for it is X bar, and I know that seems a little bit too obvious, but that really is what we call it. X bar, which refers to the mean, is the sum of all of the X values divided by the number of values. So in other words, you need to add up all of the X's and then divide it by how many of those numbers you added up. So that's an X bar, and sigma, or the summation of X, divided by N. Now, so here's an example of that working out, and we're going to come back to this example on several different slides. And to speed things up a bit, I have most of the examples already worked out on there because I don't think the process is going to throw you off as long as you have something to go back to. But if you have a list of numbers, so this is a data set, it's really small, but it had quite a few more numbers in it, but we've only picked out some of them. And so if we have these 5 numbers and we want to find the mean, we have to add all 5 of the numbers and then divide by 5. So notice that all of the numbers we added had 1 decimal place, but when we have our answer, we have 2. Just kind of keep that in mind. We're going to talk about rounding later. You could get a mean from a frequency distribution, and that's where, remember on our frequency distribution, we have a particular range, but instead of using the range, you're going to want to use the class midpoint. Maybe it'd be good right now if I just kind of underline that, because instead of taking just the X value, which you don't have anymore, you're going to have a range on a distribution, and so you just find the middle of it, like when we talked about the McDonald's drive-through times, and then multiply that times the frequency. Then you add them all up and divide by how many there are. So the frequency, so if you have a table, you'll actually end up going straight across that table, the midpoint times the frequency, and multiply that out, and then you divide it by the sum of the frequencies. Now this actual value, this X bar, I have a note here, that ends up being approximate, because since you're using a midpoint, you don't have your original values. So it's actually best to do the mean if you have access to all the original values. But if you don't have that, then you can use a mean from a frequency distribution. Since it does use a class midpoint, you would need to tell people that. And if you're looking at some information and it tells you that it's from a frequency distribution, you just have to know it's a little bit more approximate, okay, not quite as exact. We also have something called a weighted mean, and it's calculated really in the same sort of a way a frequency distribution mean is. It's just that instead of having a frequency, we have a weight. And instead of having a class midpoint, you're going to have a value you use. However, that value might come from some sort of a mean, because like in this class where we use a weighted average or a weighted grade, you could calculate a weighted grade by taking the weight times your mean or your average within that category. And so that term of average is, though, that mathematical or arithmetic mean. So if you wanted to take your homework grade, your homework average, times the weight that your homework is counted, you add all of them up, and then ultimately, so every category's grade times that category's weight, add them all up and divide it by the total weight. And for that to work, the total weight does not need to be 100. When we do grades, we generally make our weights all add up to 100. It's just easier for everybody to understand. But as long as you divide it by the total weight, it doesn't have to work like that. We could just use proportions and say this category counts for twice as much as that one. Okay, so about the mean, some important properties. We have a couple of key words here that are new vocabulary for us. One of them is reliable, and the other one is resistant. If it doesn't vary a lot when you have different samples from the same sort of population, so you take different samples from that same population, then it's considered reliable. No matter which sample you use, you're going to get an answer that's very close to the same thing. And that's reliable, and a mean is reliable. It uses every single data value when you are doing just that direct arithmetic mean. It doesn't use every data value when you have a frequency distribution. It does use them all, but it's still rounded off because they're in there. It's just kind of like, I want to say, like finding the egg in a cake. You can't get your exact data values back out just because you know it's in there. However, if you have one outlier, it could change the value a lot. And many people have experienced that in a classroom, maybe in high school or something, where there was a test and it seemed really difficult, and then you have that one student who aced it. And so the class average, you know, the teacher's like, well, the class average really isn't that bad. That teacher's referring to the mean. But what's happened is that because you had an outlier, it really threw that mean off. So an outlier changes things a lot, so it's considered, the mean is not resistant. So if you have an extreme value and it doesn't change something much, then it's called resistant. Now, I have a note on here, the tail pulls the mean. I've got a slide a little bit further down about that. But when you have a normal distribution, the mean, mode, and median all happen at that really high center hill. However, if you get a distribution that's skewed, remember, and the tail is longer on one end than the other, the mean gets pulled off of the center hill and gets pulled out towards the tail, which means if you had, back to our class example, if somebody aces that test when most the other people, you know, maybe made a C, then that mean is going to end up higher than the C. It's going to end up closer out at the end, okay? So I'll explain what that means again when we have our visual, but this is to kind of help you remember that the mean is not resistant because the tail pulls the mean, and I say it like that because, again, just how do you remember this? I always said it's mean to pull something's tail, but yet in statistics, the tail pulls the mean. Okay, so let's move to median. The median is the middle value, just like the median of the highway is in the interstate, is that middle section that separates southbound and northbound or something. So it's that middle value, but make sure that you have all of your values arranged in order And it doesn't matter if that order is increasing or decreasing. We usually line them up increasing, but that's not really the issue. It's just that you need to have them in order. Then if you have an odd number of values, you can just kind of count off and say, well, you know, like if you had 5 values, the third one's going to be in the middle because that'll give me 2 above it and 2 below it. However, if you have an even number of values, suppose, I mean, we wouldn't calculate the median with just 4 numbers generally, but just to help you understand, if we had an even number of values, then we don't have one value right there in the middle. It's like we have 2 middle ones, and so you add them and divide by 2. So the median isn't always an actual data value, and neither is the mean. The mean does not have to be a data value. But if we're going to find the median, so here are those same 5 speeds that we found the mean for. If you line those 5 speeds up in order, then this one is in the center. However, if I added another data value, then I would take 2 of them and add and divide by 2. So if you don't have a 1 in the middle, you take your 2 in the middle, add and divide by 2. On the median is, and we've used this word already, but the median is resistant. That means that it does not move as much. It does move a little bit, and you're going to see that again when I have the visual. It moves a little towards the tail, but not as much as the mean. And it does not use every data value. If you were to go back, and we're going to look at our example here, if I get rid of this 55.6 and throw it out, and then I replace it with a number like 47.2, it doesn't change the median at all. This would still be the middle number. So it doesn't change a lot just because you change those particular things. This 14.1 isn't used in this calculation at all. Okay, and that's what it means where it says it doesn't directly use every data value. Yes, you're counting off, but you can trade out a data value and it doesn't change anything because it was just simply that one in the middle. So now into mode. Mode is the one that occurs with the greatest frequency. I like to say the mode occurs the most. They kind of sound the same. Mode is the most, median's in the middle. The average person is mean, so you calculate that one like an average, even though we shouldn't call it that. But now a data set could have one mode, more than one mode, or no mode, because maybe everything occurs the exact same number of times. And if that happens, it's no mode. If you have 2 values that are clearly more than the other ones, and they occur the same number of times, it can be bimodal. And when you have more than that happens, we don't use it as often because it's a little bit less important to us if it's happening a lot, but it could be multimodal. So usually we say no mode, or we have one mode, and occasionally we deal with bimodal. Very rarely would we ever deal with the multimodal. If we're going to find the mode, and this one's not pre-done for us, but if we were going to find the mode, it helps to have them lined up in order. Here they're not, but you're just wanting to visually inspect the data and see, does one of these values occur more than another one? All of these values occur one time. So on this one, there is no mode. However, on this one with Sprint, if you look along the lines here, you can see, and they don't have to be sorted when it's a really short data list. If it's long, you'll really want to have it sorted. But we have 0.3 that occurs 3 times. Nothing else occurs that often. So this one is 0.3 is the mode. So you're just looking to see what occurs the most often. It could be none, probably one thing, could be 2 things. The mode is the only measure of center that you can find with qualitative data, which means you don't have to have numbers to find a mode. You could take a survey and ask a lot of people, what is your favorite color? And you can still come back and say, the response that occurred most frequently was. And when you can say what occurs most frequently, even if it's not a number, that's the mode. So mode is the only one that doesn't have to have numbers. It's the only one that works with qualitative data. And it's the only measure of center that can have more than one value or no value at all. So now let's look at our little chart. I kept saying we were going to look at a visual. Now, if you have distributions, they don't have to be curved. If there's no mode, then you're looking at a uniform distribution where it's just kind of straight across. Because otherwise, there will be a value. If it's not straight across, then there's a value that occurs more than the other ones. If there's a value that occurs more, you have a mode. So here we have 3 different distributions. Remember, skew is named by the tail, so this one is left skewed, and the one on the right is right skewed. But let's start with looking at each thing. The mode is the highest value on all 3 of them. The mode is the most, and it will always be the highest value. The mean, median, and mode are all at the same place on a normal distribution. Mean, median, and mode. And if it's approximately normal, all 3 of those values will be really close together. However, I said the tail pulls the mean. So once you have a skew, once you have a tail that heads out, the mean gets further out into there. That's because it's not resistant, and it moves if you have one of those outlier values. You know, that person that made that really high score pulled the class mean up higher. Now the median is more resistant than the mean, but it's not entirely resistant. It moves some. So how are you going to remember which one's in order? Well, median is generally a middle value. And even though it might not be in exactly the center, the median will always occur somewhere between the mean and the mode, just like the median occurs between other data values. So the median occurs between them if it's skewed. Might not be exactly the middle, okay? The median is between, and the mean gets pulled out into the tail. If it is a normal distribution, they are all 3 in the same place. All right, so let's move on a little bit because there are some values you can't just get at a glance from a distribution, and mid-range is one of those. The mid-range of a data set is the value midway between the maximum and the minimum. Now, if you do the maximum minus the minimum, that's the range. So the mid-range is actually the range divided by 2. Back to these 5 little numbers, we've used them again and again and again. And does this one say minus? You can use that to get there, but it really shouldn't say that, guys. I have to make corrections along the way sometimes. It's not a range, because if you subtract them, you get the range. But when you're trying to find the mid-range, you add and divide by 2. If you were to subtract and divide by 2, you would know how far to move up from the minimum. But the fastest way to get there is to add and divide by 2. So here, if we take the maximum and the minimum, it doesn't really matter the order there. You just find the high and the low. So we had this 55.6 and a 14.1. You add and divide by 2. And that's the mid-range. Now again, if you wanted the range would be 55.6 minus 14.1. And that tells you how big of a spread we have on our data. But the mid-range tells you just kind of what the middle of that x-axis would be going across. It is very sensitive to extreme values, so it is not resistant. It is the most sensitive because only the extreme values are used in its computation. So if you change an extreme value, this one's going to change a lot. Now, because it has that word mid in it, sometimes people get it confused with the median, but it's not at all the same. The median is actually that middle data value. But the mid-range is just telling us what is in the middle of our entire spread of data from the highest to the lowest. And it's not going to be the same. So you got to make sure you keep those separate. But it is not resistant because it only deals with those extreme values. So certainly anytime you have an outlier, it's going to change it a lot. Okay, now I mentioned that we would go back to the rules for rounding. And I pointed this out when we did the mean, but I didn't say it specifically on all the other ones. For the mean, median, and mid-range, you carry one more decimal place than the original set of values has. So again, I pointed out that we were doing things that had one decimal place. And all of the examples we had 2 decimal places. It might come out that way anyway, but if you have a lot of decimals, you go one more than what it had. And don't round in the middle of your calculations. That can throw your answer off. You want to only round the final answer. So don't round in the middle, even if you don't want to write all those numbers down. You just can't do that. For the mode, you're not going to round at all, so this doesn't apply to the mode. So today we've talked about mean, median, mode, and mid-range. The mode you're not going to round. It is one of your original data values. It's the value that actually occurs the most. So you shouldn't have to round it at all. It's one of your data values exactly. Now this is just hitting some notation again. So I've already mentioned this. This is sigma, and it's a capital sigma. We do have lowercase sigmas and some other notation. And I'm sorry, there just weren't enough letters in the alphabet, I think, for them to do statistics. We had to have more symbols. But this is really a shortcut symbol. It means add everything up. Okay, it's the sum. And X is generally what we use to represent an individual data value, so it could just depends on what the study is. N is how many of those data values we have. And if it's a lowercase n, it came from a sample. And if it's an uppercase N, it came from a population. And that doesn't actually happen a lot because, again, we rarely have access to the entire population. And again, population isn't referring to people necessarily, it's just all of whatever you are studying. But the study of people is some of the most intriguing things out there. So however, lowercase and uppercase, N is the number. X bar is the mean, and that's what I've used in this and what we were dealing with today. But X bar comes from a sample. Okay, X bar comes from a sample. Mu actually is also a symbol for mean, and this weird little, in other words, we've got another little Greek letter here. Mu is the mean of the values of a population. So since it changes to population, the formula changes slightly. If we're doing X bar, we add all the data values from our sample, and then we divide it by the number of values in our sample. If we're doing mu, we add all of the data values from our population, and we divide it by the number in our population. So we see just a slight difference in notation there. But once you learn it, it is faster to write this symbol than it is to write the word population. Now, the next couple of slides are really not about the information. It's about how to help you on your homework. So these are probably pretty important slides to you. When you're in StatCrunch, this is a slide you might want to pause it on or take a picture of. A lot of times there's a data set, and there's a little box above it where you can open in StatCrunch. We've mentioned this on another little thing. But here, summary statistics, descriptive statistics or summary statistics is where you find mean, median, and mode. Well, actually, it's not going to do mode, but I'm going to mention that. But it will find a lot of stuff for you. It finds a lot of information for you. Save you some time. So when you're in there, after you open it up in StatCrunch, then you are going to click on Stat. That's this very first arrow. And then Summary Stats, and then choose Columns. You might just have one column open. I happen to have two when I took this screenshot, so you could do 2 columns or you could do 1 column, but you click on it, move it over. If you want to choose more than 1 column, like here I had male and female information because there were 2 rows up here, then I think I hit Shift. It does tell you in StatPlots what to click on, but I think I hit Shift and selected on both so they would both move over. And then you're going to hit Compute. So what information is that going to give you? This is going to show you more information than you even need yet, but this is what comes from it. Now, some of this stuff we can use in later chapters, but if you look then, you can just go across and it tells you the mean, it tells you the median, and you can easily calculate the mid-range because remember the mid-range is the minimum plus the maximum divided by 2. So it tells you which value was the minimum and which value was the maximum. And if you go back to what we originally had, it's not that you couldn't find those numbers, but it's just a little bit blinding to stare at that many numbers and try to figure out which one's the smallest and which one's the largest. So here it just gives you that minimum and maximum. It also gives you the range. It gives you the Q1 and Q3. So there's other things that we can use. And later on in other chapters or other sections, we're going to be talking about variance and standard deviation. So those values are going to come back up and be important to us also. However, you cannot see the mode from this list. But StatCrunch can help you find the mode even from a long list. So back where if you open something in StatCrunch, and again, this is where I had both male and female columns here, then you can click on one of your columns, and at the top, and a little drop down pops up. And then you can choose sort table ascending. And you could sort it descending. That's not going to make any difference, actually. And then it will put all of the numbers in order for you. And that makes it much easier to see, oh, look, here is a row of values right in a row, and you can see which one is the most by just kind of scanning it that way. So you do have to visually inspect it, but you can get StatCrunch to help you sort it, so all your numbers will end up grouped together, and it makes it easier to see if one number appears more than the other one. So I hope that's helpful. If you do need more help, StatCrunch has a lot of instructional videos about how to do statistics, so you can check out a YouTube. When you go into StatCrunch, I think you can find a way to navigate there, but you can go to YouTube and look up StatCrunch how-to videos. Now, your TI-84 is also going to do statistical calculations, and we are certainly going to be using a TI-84 during this class. So if you don't have one, you need to get one, or you need to make sure you have a good simulator. You could use an online simulator. You might be able to find a good app that works for your phone that works like a TI-84. But instructions that we give you for a lot of things, if it's not available in StatCrunch, I'm going to be telling you how to do it on a TI-84. Furthermore, when you need to do something, the textbook has detailed instructions about what to click on how to do something on your TI-84, and you generally have those at the end of each section. We don't want to use it if you don't have to, because if you have to retype the list of numbers, sometimes that's just, we're prone to errors. You're going to make a typo sometimes. But if that's what you need to use, even when you're doing your homework, if you'll say, that you need to reading the textbook, just flip through a few pages and it'll tell you how step-by-step instructions on how to do things on your TI-84 Plus. Okay, so some homework tips there, and make sure you do get the calculator, because we will need it some if you don't already have it. And I would recommend getting a used one. You don't need a new one. You don't need a color edition. If you can get to McKay's at Chattanooga, that used bookstore, they generally do have these used calculators for somewhere around 50 or 60 bucks. I mean, anything could change, but hope that helps. Don't forget, just send me a question if you need help on your homework. Thanks.